Assalamualaikum to our beloved lecturer Dr. Noor Asma Osman and Puan Syairul Rohaizawati Samad. I am ARIF HAZIQ bin KAMARUL BAHRIN with my group mate Muhammad Afiq bin Muhammad Raduan and BADRUL AMIN bin AZHAR. We present about the flow of work, step and result, how we construct Hecras model. Hecras is a one-dimension fixed flow hydraulic model designed to assist hydraulic engineer in channel flow analysis and foot plan determination. In this presentation, we are going to show the step how to use the Hec-Ras software. Basically, Hec-Ras is a software that can model the hydraulic of water flow to natural river and other channels. This software allows stimulating flow in a natural or artificial channel to calculate the water level for performing flood study and determine the area that are likely to flood. Then we are going to make a comparison between the result of river analysis under steady flow and unsteady flow in terms of flow depth, flow rate and velocity. Next, I will pass it to Afiq to present.
Alright, so for the flow works of step, so firstly we will open Hec-Ras and then we will create a new data. So for example, I will create data here. I will type as geometry and then click OK. And then I will adjust the SI unit by clicking option and SI unit. So we will click on the SI system international and click OK. And then yes. Okay, next. So I will open the folder that I already do. So here, project Hec-Ras, and for Hec-Ras data. Okay, firstly we will construct the ridge by using this button, river ridge. We will draw and then we will press the button cross section. Okay, so for the cross section, so we will draw all the ridge and then we will name all the ridge with its name. So this one is Lipis upstream, tempera, and this one is Lipis downstream. Okay, next we will assign all the coordinate by clicking this GIS tools and ridge invert lines. So from here we will take the values from the data. So for the Lipis river and Lipis upstream, here we can see and schematic X and Y. Just copy all the data and insert here. So we will do as well for the tempera river, tempera, and also the Lipis river and Lipis downstream, and click OK. Okay, next we will click on the cross section icon and insert all the data from Excel. So this one for the Lipis river and Lipis upstream. Okay, this one is for station 10.212. Just copy all the data and insert all the data for station and elevation. And for the downstream ridge and also the manning value, we will use this value from the question, our matrix ID 315. So we will insert in all the station following all the data given in the Excel for all stations. And then repeat the same method for the tempera river and also Lipis river and Lipis downstream. When you already put all that, click on the junction icon. Okay, and then we will save it as the Hec-Ras data. And then we will open the data here in the folder. Copy the Hec-Ras data and make two folders, Hec-Ras steady flow and also unsteady flow. So here I will open firstly is the Hec-Ras steady flow. Hec-Ras data, Hec-Ras steady flow. Okay. So firstly, I will click this one, view or edit steady flow data, and insert all the value from the Excel. Okay. Here, okay, 10.212, 10.0191. Okay, all this, and then we will click on the ridge boundary condition. Okay, here, ridge boundary condition. And then insert all the value Alright, click OK. And then we will click perform steady flow stimulation. This one. And then just click compute. So we wait for a while. Then it already complete the run. So it will finish. So we can view option view profile summary table. Okay, this is the profile summary table. For other reaches, you can add all reaches and view all the value for Q, velocity or elevation. Okay, next for the unsteady data, you open unsteady flow and do exactly same all the thing and insert all the Hecras by using all the data from the unsteady flow data. And then you can click same also, view, profile summary table, option, click on the reaches, and then add all the reaches. And you can see all the values for velocity, flow rate, elevation, and everything for the each one of the river and also reaches. Okay, and then you can take all the value and insert it in your report. Okay, that's all. For the result, I will ask Badrul Amin to continue.
Thank you, Afiq Raduan. So my name is Amin AZHAR and I will conduct about the results and the discussion. For the result, as we had discussed in the Hecras software, we had been insert the data on the Hecras, and this is the result for Lipis River upstream, Lipis River downstream, and Tempura River drainage. For the discussion, we compared three main points, which is that we compare between the steady flow and unsteady flow. For the first one is flow depth, and from the result above, we can notice that for Lipis upstream, the steady flow has deeper flow depth if compared to unsteady flow. The flow depth of steady flow in Lipis upstream in range 79 to 76 meter. However, the flow depth of unsteady flow is in range 77 to 74 meter, which is shallower than the steady flow. For the Lipis downstream, the flow depth of steady flow is still deeper than the unsteady flow at every station. For flow depth of steady flow is in range 78 to 76 meter, while for the unsteady flow is in range 76 to 73 meters. Moreover, the flow depth of the steady flow for the Tempura River is deeper than the unsteady flow. Next, for the second component is flow rate. For steady flow in Lipis upstream, the flow rate is 2,250 millimeters square along the river. For unsteady flow, 1,511 and 0.56 to 2,040 meter cube per second. And for the last point is velocity. The velocity obtained in Lipis upstream for steady flow analysis are 2.6 to 2.96 millimeter per second. For unsteady flow are 2.69 until 2.90 meter per second. And then we can observe that the velocity varies along the river no matter it is steady or unsteady flow, which means at each station it experiences its own velocity of flow, but the velocity does not change with time. Okay, that's all from me. I will pass the presentation to HAZIQ.
So to conclude, we are as team can cooperate well with each other to finish this project. This project also advanced our understanding about the concept of steady and unsteady flow. We also learn how to use the Hecras software to analyze the properties of flow and obtain the data. So these are the reference that we refer to complete our project. That's all from us. Thank you.